Hi folks, welcome to another day of math videos, algebra videos. Today we're going to explore more characteristics of quadratic functions. We're going to be using our calculator, our graphing calculator, or in class we'll talk a little bit about Desmos.com. So make sure you start bringing your graphing calculator to class and or also have your Chromebook to be using Desmos. So actually I want to start today with a joke that my youngest child told me, and he's a jokester, so he loves to hear jokes, and then he does a good job of remembering and sharing. So his joke is, what is the smallest room in the world? The mushroom. So afterwards, I actually told him that the largest organism is actually a mushroom that lives underground, which is another kind of cool fact. Anyway, coming back to these notes, we have this function, negative x squared plus 9, and then what we have right after that is something called end behavior. This negative 4 is less than x, which is less than or equal to infinity, which looks like I think I have my signs backwards here. So let's go ahead and fix that, and then we'll get rid of that. So that is what it should be. So we're going to use this to help us as we come up with our end behavior. The first thing that we're going to do is go ahead and put this into your graphing calculator. So you start by going to y equals. If you have something in there, you're going to hit clear. And then it is going to be, let me actually zoom out the ladybug a little bit. That way we can get more of the graphing calculator. Negative x squared plus 9, okay? And then you're going to go to graph. You see your parabola in there, but we're actually going to jump to the table, so second table to jump to that table. And what we're going to do, we're going to fill in this table. When we fill in this table, it starts with x is negative 4, and so we get negative 7. So you guys can kind of see. Then 0, 5, 8, 9, 8, 5, 0, negative 7. We'll put the graphing calculator off to the side and answer some of these questions and graph. So actually, let's go ahead and start graphing first. What I want to point out is we have this 0, 9, and we're going to circle it. This 0, 9 is our turning point, our vertex. And you'll see as we graph 0, 9, here it is. Then I have 1, 8, negative 1, 8, 2, 5, negative 2, 5. Then I have 3, 0, negative 3, 0, 4, negative 7, and negative 4, negative 7, okay? And then just sketch what we get. Okay, our y-intercept, in this case, it is 0, 9. The zeros where they intersect the x-axis, we can look at, again, when we're answering these, the graph or the table, it's negative 3, 0, and 3, 0. Axis of symmetry, remember, right here, this is where the parabola reflects itself, and we always read it where along the x-axis, so it's x equals 0. The vertex, also known as our turnaround point, is 0, 9. Okay? Whenever you are creating these tables, so this is important, I want you to be circling your vertex, and I want the vertex in the middle of your table. So a lot of these tables are odd numbered, so this one is 9. Sometimes you'll have 5 or 7, but I want that vertex in the middle of the table so you have kind of your even points on either side. Now, my question is, do we have a minimum or a maximum? We have a maximum. We have a highest point, so we're going to go ahead and circle that. The domain in this one is actually our end behavior right here. So if I go back and I actually went ahead and graphed this so my arrow went on forever. And so I'm going to have to erase this. And this happens, you know, where you realize, okay, my domain, it actually starts at -4, and then it's all the x values to the right of it, okay, or as it's increasing. So my domain is given to us. It is this end behavior. The range, it's -infinity. Okay, even though this -4, -7, this is where it starts according to domain, but my range can be -infinity because it is from the other side of this parabola. Okay, it will go into start at -infinity, but it stops at the maximum, and the maximum is 9. We're going to have it equal to 9. Increasing, we're going to remember, so it's always as we travel left to right how we move along the parabola. So we are increasing from the left to the vertex. Okay, so we are increasing from -4 along the x all the way to 0. We decrease along our parabola from 0 all the way to infinity. Okay, so again, along with your x values. Okay, and this one can actually equal 4. Remember, along the turning point, along the vertex, it will never equal. Okay, because it cannot be increasing or decreasing at the same time. The next thing we're going to do is we're going to do a quick review of average rate of change. Okay, remember, average rate of change is the change of y over the change of x. What I'm looking for is the change from -4 to 4, and we subtract to find that average rate of change. So at -2, if I look at my table, my y-coordinate is 5. My x-coordinate, again, if I look at +4, the y-coordinate is -7. Okay. When I work this one out, 2 minus -7, minus a negative is plus a positive, so I have +2 over -6. This simplifies to -1/3. Okay. So there we go on that first one. Let's try this again. So go ahead and flip to your second page. So for your second page, what we have, this time take a look, my table is not filled in. So we have x values, and then I look and I see they give us an f of x. If they had a y, I would be filling in y, but they have an f of x. So we're going to fill that in. I'm going to pull out my graphing calculator again. Let's actually move the paper off to the side. Readjust. Okay. I'm going to go into my y equals. I'm going to go ahead and hit clear. And then I'm going to type in -x minus 6x minus 5. Okay. We're going to go to graph. And not quite fitting on there. But we can go to our table. And if I look at my answer key, I must have entered a different graph. Oh, sorry folks, I did not put x squared minus 6x minus 5. Now when I look at my graph, there's my parabola. All right, now let's go ahead to that table, and I'm going to scroll back to where I should be. I'm looking for my vertex. And right here, I know this is my vertex because I start seeing my y values repeat on either side of that turning point, okay, of that vertex. So I have a total of 9 right here, so I'm going to count down to 5. 1, 2, 3, 4, 5. I'm going to fill in my vertex, -3, 4. Okay, I'm going to circle it because that's something that's required. I'm going to go ahead and fill in the rest of my x values according to that. So -2, -1, 0, 1, and then in the opposite direction. And I'm going to fill in what I can see, and then I can go back and anything else that's missing. I have negative 12, and I know I'm going to have negative 12 down here. I can even scroll with my graphing calculator, and I see I also have negative 12. All right, so let's go ahead and put our graphing calculator off to the side and fill in a graph this. So I'm going to go ahead and start with my vertex. My vertex is negative 3, 4. From here, I have negative 4, 3, negative 2, 3. My x-intercepts. Then we keep going. 0, 5, negative 6, 5, and it looks like 1 and 12 are kind of off the graph, and that's okay. That will happen every once in a while, especially when we have so many values to fill into our tables. Okay, so I'm just going to fix this a little bit. I like things neat and accurate. There we go, a little bit better. Now let's find our y-intercept. Y-intercept is right here. If I look at the graph, I can also see it at my table. So it is 0, negative 5. My zeros are my x-intercepts, also known as solutions. Okay, so I have negative 5, 0, and negative 1, 0. My axis of symmetry, okay, where this parabola is cut in half, where it turns around, it is on the x coordinates. That's what we're looking for. It's negative 3. So x equals negative 3. The vertex, the actual turnaround point, negative 3, 4. Okay, looking at this, this is a maximum again. Okay, now domain and range. I look up here. I do not have n behavior. So when I do not have n behavior, my parabola starts negative infinity all the way to positive infinity. I'm going to show you the other notation. Put that in there. My range, negative infinity is where it starts. So you go from bottom to top. And it stops right here at positive 4. And this is where I have a bracket because it equals 4. Increasing, again, as we travel from left to right, okay, in this direction, as we move along this parabola, okay, so it increases to this direction and goes back down. Again, as I travel from left to right, it's kind of how that parabola rides. So it is negative infinity, and we have to include the x on this one. And this is my negative 3. Decreases from negative 3 to positive infinity. Okay? All right, that's it. We're going to go ahead and do the rest in class. We're going to pull up Desmos and kind of practice as well with the graphing calculator. Even though you prefer Desmos, because I know some of you do, you need to practice with graphing calculator. It is really nice when you're taking your online test to have a handheld, okay, rather than flip screens back and forth and make mistakes that way. It's also nice to double check. Okay, that's it for these notes.